Hey, this time we're going to be working with a triangle. No, a rectangle. I need to get my angles corrected. Alright, what does this thing say? It says the area of a rectangle is 42 square feet. Wow. The length is 2 feet more than 4 times the width. What are the dimensions of the rectangle? Well, let's draw a picture. Let's draw some kind of picture here. The picture. Okay, let's try to get it to scale. The length is 2 feet more than 4 times the width. Ooh, let's see, what kind of scale are we looking at here? Okay. I'm just guessing what this thing looks like. Let's see. I don't know. We'll say that right there. How's that? I should have made that a different color. I don't know why I didn't do that. Here, we'll do this. Okay, we're going to let this side here be the length. Well, I always forget to... We'll let this side be the length, and we'll let this side over here be the width. Now... I consider the length always the longest side. I don't know. Seemed like I was watching something not too long ago and somebody considered the longest side to be the width. I can't remember what I was watching. It wasn't even a math video or anything. Anyway. Alright, so let's write our equations out, because that's what we need to do. Write the equations. So we're talking about area here, the area of a rectangle. So in other words, the area is going to be equal to the width times the length. Okay, so that's our area. Now, let's read what it says here. Oh, let's see, the area is 42 square feet. So we know that. We know 42 is going to be W times L. Now, let's look. We got a relationship between the length and the width here. It says the length is 2 feet more than 4 times the width. The length is the key word for equal, is 2 feet more than 4 times the width. 4 times the width and 2 feet more than. So 2 feet more than 4 times the width is 4W plus 2. Okay, so now we have a relationship between L and W. So now what we'll want to do, I'm just now recalling a strange dream I had last night. It was bizarre. Anyway. How weird. Okay. I don't know how this problem's got anything. Maybe I saw that WL thing in a dream or something I had last night. I don't know. 42 is equal to, so remember it was W times L, right? But W's is W, and we know that W, or L, is 4W plus 2. Wow, I was just thinking of this dream I had, man. It was really detailed. It was looking down at a map. I don't even know. I'll have to contemplate this after this problem. Okay. Let's go ahead and, the goal here is get this thing in that quadratic or standard form. Get our quadratic equation in standard form. That's the goal here for right now. So let's distribute this W across. So we have 4W squared plus 2W. All right, we'll go ahead and rewrite our 42. And now what I'm going to do is magic. Okay, I'm going to take this 42 and take it over. Now, what am I doing? I'm taking the 42 over here. Okay, you know what I'm supposed to be doing. 42, just take it over. Forget about it. In other words, we're subtracting 42 from both sides. All right. Don't let this thing throw you off. I got the 0 over on the left. Don't worry about all that. Now remember, we need a positive coefficient, and we do. And we look at all these, and is there a number that goes into evenly on all of them so we can factor it out? And it looks like this actually 2 is going to be the only one. So let's do that to help us simplify this down a little bit. We go to try to figure it out. Right, so 2 goes into 4 2 times, 2 goes into 2 1 time, but we're just going to write W. And then 2 goes into 42. Ooh, goodness. 21 times. All right. So now what we want to do is factor this guy. So, we know that we'll have to write 2W there. Put the W here. Okay, so two numbers multiplied together, it gives us 21. And actually it's going to have to be a negative 21. And this should be pretty simple. It's either going to be 1 and 21, the two numbers we're looking for, to multiply together to give us negative 21, or it's going to be 7 or 3. 7 or 3? Is that what I said? Which I think that's what it's going to be. So, let's see. If I put a 7 here, we just got to guess this out. I put a 7. Let's see. So we have 2 times 3 is 6. And 6 and 7. Yeah, okay. So one of these got to be negative. And then we got a positive 1 up here. So obviously 7 will have to be the positive. Yeah, minus. Okay. See, I could have flipped this around and put the 3 here first and the 7 here. But, all right, so we got it. I think we got it there. Yeah, that would give us 2W plus W minus 21. We multiplied it out. All right, so what we'll need to do now is set both these factors equal to 0. And, of course, we don't have to worry about that 2, because you multiply both sides by half, the 2 just disappears. You got to worry about it. And W minus 3 equals 0. All right, so we solve for W in both these linear equations, and we get W is equal to, taking the 7 over to the right, you get negative 7, and then multiplying through by a half to both sides. So we get the width is negative 7 halves, but we know we can't have a negative, right? And then this other one is W is equal to 3. Okay, solving for W in that linear equation. So it looks to me like this is going to be the winner. So we know what W is now, finally. So W is going to be 3. And L, what we'll have to do is plug W in right here. And you know what? We'll just do that right here. L is equal to 4 times 3 plus 2. So that gives us 12 plus 2. And that gives us 14. Looks like 14. 14. And this is definitely not to scale. If the width is 3 and the length is 14, the width is 3 and the length is 14, the length is 2 feet more than 4 times the width, right? 4 times 3 is 12, and then 12 plus 2 is 14, so there you go. Okay, we spent almost 10 minutes on this problem. When you're taking a test, you probably need to get it done in about 1. Alright, so that's the whole complete process of solving this problem. Hopefully you got it. and you can make up some of your own. Now, this is a rectangle. We could have been, this could have been anything. Somebody's garden. Somebody was fencing in their pigs. Or a kangaroo. Chickens. Building a house. I don't know. It could be anything, right? All right. We'll see you over here. I think we got a farmer problem coming up here. All right. See ya. See you in the next one.